Vaccines are made up of several components, each of which has a specific purpose to ensure safety, efficacy, stability, and ease of administration. The main components of a vaccine generally include antigen. The antigen is the core component of a vaccine and is typically a small, non-infectious piece of the pathogen, like a protein, toxoid, or inactivated virus or bacteria. It acts as a target for the immune system, helping it recognize and remember the pathogen. Upon future exposure, the immune system can quickly recognize and neutralize the actual pathogen. Adjuvants. Adjuvants are substances added to some vaccines to enhance the body's immune response to the antigen. Common adjuvants include aluminum salts like aluminum hydroxide or aluminum phosphate. They help stimulate a stronger and longer-lasting immune response, allowing for fewer doses or lower amounts of antigen. They also improve the vaccine's efficacy, especially in individuals with weaker immune systems, such as the elderly. Preservatives. Preservatives are added to prevent contamination by bacteria or fungi during storage or use. One of the most common preservatives is thimerosal, though it is rarely used today in routine childhood vaccines in many countries due to public concern. They extend the shelf life of vaccines, allowing for safe multi-dose vials and reducing wastage. This is particularly important in regions where refrigeration may be inconsistent. Stabilizers. Stabilizers are compounds that help maintain the vaccine's effectiveness during storage. Common stabilizers include sugars like sucrose and amino acids like glycine. Their role is to prevent vaccine degradation by stabilizing the antigen, protecting it from temperature changes or light exposure. This stability is crucial for transportation and storage, especially in regions without consistent cold chain infrastructure. Diluents. Diluents are liquids, usually sterile water or saline solution, used to dilute a vaccine to the correct concentration before administration. Many vaccines, particularly freeze-dried ones, require reconstitution with a diluent before use. Their role is to ensure the vaccine is at the correct potency and concentration, allowing for accurate dosing. Residual inactivating agents and antibiotics. Residual inactivating agents are used during vaccine manufacturing to inactivate the pathogen or detoxify toxins. Formaldehyde is a common inactivating agent used in minute amounts. Antibiotics like neomycin may also be used during production to prevent bacterial contamination. The trace amounts of inactivating agents ensure the pathogen remains inactive, providing safety. Residual antibiotics prevent bacterial contamination during manufacturing, ensuring the vaccine's sterility. Summary: antigen triggers immune response. Adjuvants boost immune response. Preservatives prevent contamination and prolong shelf life. Stabilizers maintain vaccine effectiveness during storage. Diluents adjust potency for accurate dosing. Residual agents and antibiotics ensure safety and sterility during production. Each component plays a crucial role in ensuring that the vaccine remains safe, effective, and stable for use, particularly in diverse storage and transportation conditions across global health systems. Nature is ultimate.